Hi, Nehal.
Hi, Ricky.
Hey, Kai and Nehal.
Okay, I know you guys have been plotting about something to do today, and I have no clue what it is. So take it away, guys.
Yeah, so today we will basically introduce the idea of smart contracts on the blockchain through a hopefully relatable example. And we will then visualize the number of users that are interacting with that protocol that we will cover today, as well as kind of the dollar amounts that are passing through it. So first thing we'll do is we'll go back to TxStreet, which is the website that we covered in our last video, which we're viewing right now. So last time we discussed how this website is basically showing us the Ethereum blockchain in real time, and that each of these little people being displayed is a transaction that's getting in line to be written on the blockchain. And here on the left side, we can see that the people are coming out of specific little homes. So these are essentially transactions that are interacting with specific smart contracts relating to specific blockchain protocols. And one of these protocols is the one we'll cover today, which is this one called Compound. And if we click on this, we'll basically see the most recent transactions that happened on the Ethereum blockchain relating to Compound. Basically, in our last video, we visualized some data for a protocol called Uniswap, which essentially allows users to trade assets with each other through smart contracts. But we didn't actually talk much about what a smart contract is and why it's important. So today we're going to basically look at another protocol called Compound, which is this one that we have pulled up, which provides a money lending market through this idea of a smart contract. So at a high level, Compound basically allows users to provide some assets that they already own. So something like the Bitcoin or Ethereum that they already own, and basically provide that as a monetary supply that other users can then borrow from and take a loan from. So basically, once a user has made some assets available to the protocol, they can then leverage those assets as a collateral to take out a loan that's basically smaller than the monetary value of the assets that they provided. And that sounds a bit complicated, but we actually think this is a very relatable example because it's very easy to compare to how a traditional banking system would work. So let's talk about how a traditional bank would work and turn a profit. Most of us are comfortable with the idea that you basically trust your bank to safely store your funds and you provide them with your money. And in return, they kind of give you peace of mind as well as a very, very small percentage of interest. So typically in the US, you get 0.01% interest is what you would typically see on the money from your savings and checking accounts. And what the bank does is it then takes that money and it loans it to borrowers who are happy taking that loan for around 10 to 15% interest. So there's basically this really big gap, and they can essentially take that difference as a profit for the services that they provide. So under a smart contract, you essentially get much more dynamic and efficient markets because a smart contract can essentially fill in the role of that trusted third party that the bank was previously performing. So in Compound here, we'll see we'll have a lender, we'll have a borrower, but we'll actually have much more dynamic markets on both sides where the interest rates are actually determined by a free market. And Nehal will now show us the Compound website and give us an overview of what those interest rates actually look like on their site.
So this is Compound's website, and as you can see, we have a detailed market overview of the total supply as well as the total borrow. So here we also have the top three markets for supply as well as borrow. And now if I go down to an in detail view of each of the markets, for example, I can refer to the USD coin, which holds the value of $1 and is the stable coin. So here the supply yield is 1.65% and the borrow one is 3.23%, which is much more efficient as compared to a normal bank.
So Nehal, so when you say supply, that means that if I lock my money into this protocol, I will get 1.65% of whatever I lock down annually. Is that correct?
Yeah, that's correct.
Okay. And I can borrow at 3.23%. I noticed the list at the top there. If you could go back up again, I was curious about that. So it seems like people are locking down Ethereum and US dollar coin, but they are borrowing DAI, whatever that is, and US dollar coin. So if I had 10 Ethereum and I wanted to keep that because I think it's going to go up in value in the future, could I lock it in here then and then grab some US dollar coins so that I could afford my mortgage? Is that a reasonable way to think of it?
That's exactly right.
Cool.
Okay, so we'll jump into the data now. We can fetch this data from a very useful tool called the Graph, which we had introduced in our last video. The graph reads from the blockchain and has multiple subgraphs. So here I have connected to the compound Ethereum subgraph, and now I can quickly go to the financials daily snapshot over here. So this will give me the values, total values logged over a period of time, depending upon what I search it by. So I'll search it using the latest block number. And I'll give a few fields like cumulative borrow, deposit, daily borrow, daily deposit, ID, timestamp, total borrow, total deposit balance. And I can copy the same query in the graph and run it over here.
And that provides the same output, right?
Yes, yes. So this gives us our results, and we can simply visualize it using another tool, which Ricky will go ahead with.
Okay, so we can basically do what Nehal did before. So I'm going to provide the same URL for the API that she did. Then I'm basically going to take her query in here, and you can do this from any kind of tool. GraphQL can be interfaced from any kind of tool. You can do it from R, from Python, from JavaScript. So here we're basically using a no-code tool, which allows us to not write any actual code to pull in this data. So what we have here is we created the query, which gives us the data we asked for. Then I can just decide to visualize this. So I'm going to pick this tool, and I'm going to say block number on the x-axis, and let's say total value locked on the y-axis. And basically we will have a visualization over time. And the beauty of doing something like this is that once you come up with your logic, let's say you have this chart being shown on a website, whatever code you wrote using the graph will always show you the latest data that's flowing through the protocol. So as new data flows into the blockchain, it will basically start appearing within the same query.
Why is the total here less than 2 billion, Ricky?
Because
I thought we were seeing 8 earlier.
They just deployed a new version of this subgraph. So they essentially create a new version of the database that has to be synced for all of the history of Ethereum. And it's very slow and kind of painful process to like sift this data from the Ethereum blockchain. And what the graph does is it creates an endpoint that makes that process much, much easier for us. And it gets really cool when we start serving this data over a decentralized network of many databases that are individually maintained by different users. So yeah, that's kind of what's happening here. So this data is only through block 10.5 million when the blockchain right now is up to block 14 million.
Very interesting. So that gets into some really interesting questions around updating an enormous database like this and keeping it updated and technology. It's really cool stuff. But right now they are in the middle of updating the database, which is good illustration of that. Love it. Okay. So we could, of course, do a number of other visualizations with that, but I think that'll do for today. And note to self, at some point we have to look at this technology underlying the graph. That's becoming clear to me now. So I think that's it for today. Thank you, Nehal.
Thank you, Ricky. Thank you, Kai.
Great talking as always. Thanks so much.
Take care.
All right. Bye-bye.